All right, diving in again. Today, we're going to crack open, I guess you could say, softwaretesting.pdf.
Ooh, yeah.
Which is all about really getting down to the nitty-gritty, with software testing terms. And I think everyone listening knows these are terms we hear all the time, right? We hear bug, we hear defect, we hear error, fault, failure.
It can get really confusing.
Yeah, they all kind of sound the same, right?
Yeah.
But understanding the difference is really...
It really is.
I think the document says it's like having X-ray vision into how software is built where things can go wrong.
It's true. Each of those terms is kind of like a different diagnostic code for a software problem.
Oh, I like that.
Yeah, it helps pinpoint exactly what kind of issue we're dealing with. And then from there, we can, figure out where to go, what the solution might be.
Yeah, so let's start with bugs.
Okay.
The document gives a really simple example.
Mm-hmm.
We've all seen this. It's that calculator where 2 + 2 = 5.
Yeah, the classic.
Clearly a problem.
For sure.
But what makes that a bug specifically?
It's that element of the unexpected, right?
Yeah.
So the software is behaving in a way that deviates from how it's supposed to based on its code.
Okay.
And that's the bug. Now, this calculator example is really straightforward. It's clear to everyone.
Right.
But bugs can get really, really complex in the real world.
I can imagine.
Think of a bug that only pops up under very, very specific conditions.
Oh, yeah.
Or one that just causes problems every once in a while.
Oh.
And then it goes away.
Yeah. That would be a nightmare to track down.
Absolutely. It can be really difficult.
Oh, so those bug reports that, we see when we're updating our phones and computers and all that.
Yeah.
That makes a little more sense now, right?
Absolutely.
So now how is a defect different?
Okay.
The document uses the example of a weather app that's displaying Celsius when it should be showing Fahrenheit.
Right. So the key difference here is that a defect is a deviation from the requirements that the software is supposed to meet. It doesn't actually mean that there's a coding error. It just means that there's a mismatch between what the software was supposed to do and what it's actually doing.
So the code itself could be fine.
Exactly. It could be perfect. Perfectly fine.
But if it's not doing what it's supposed to...
If it's not fulfilling those requirements...
Yeah.
Then it's a defect.
So it's not necessarily broken.
Right.
It's just, wrong.
Wrong.
Yeah. It's like getting, a perfectly good cheeseburger when you ordered a salad.
Exactly. Yeah. The cheeseburger's not broken. It's just not what you wanted.
Exactly. Yeah. Speaking of things not being quite right.
Okay.
The document then talks about errors, and it uses the example of a developer writing an incorrect formula in the code.
Okay. So this is where we get into the actual code itself, right? An error is literally a mistake that's made by the developer when they're writing the code. So you can think about a typo.
Okay.
Just like we make typos when we're writing.
Yeah.
It could be a logical error, or it could be a misunderstanding of what the requirements actually are.
So errors are kind of the root cause
Often, yeah.
of the bugs and defects.
They're the source.
Yeah. So if bugs are the symptom, then errors are kind of like the underlying disease.
Exactly.
Yeah, it's like, I don't know if you bake, but,
I do a little bit.
you follow a recipe precisely.
Right.
But the cake comes out flat because, whoops, you used salt instead of sugar.
Oh, yeah.
One little error can affect the whole outcome.
That's a perfect analogy. And just like in baking, sometimes these errors are super easy to spot. Sometimes they're way more subtle.
Right.
And you really have to analyze things carefully to figure out where that error is.
All right, well, let's move on to faults.
Okay.
This is where it feels like things get a little more, serious.
Yeah.
The document uses the example of a banking app that doesn't account for time zones. And that could lead to problems with, transactions.
Yeah, that could be a big problem.
So, what makes a fault different?
So a fault is like a structural flaw within the software.
Okay.
It's not just like a simple mistake, like a typo or something like that.
Right.
It's more of a weakness in the underlying logic or the design.
So it's like a deeper issue.
Yeah, think of it like a bridge that has a weak support beam.
Ooh, okay.
It might look totally fine, under normal circumstances.
Right.
But then if there's too much weight or stress on it, it could collapse.
So the fault itself might not be a problem right away.
Exactly.
But it's kind of just waiting to...
It's a vulnerability, waiting for the right conditions.
Oh, so it's almost like, like a ticking time bomb in the software.
Exactly.
Yeah.
And a lot of times these faults are because of more complex problems, like, maybe the design wasn't good or the documentation wasn't clear,
Right.
or they just didn't do enough testing,
So this is where things like, code reviews and documentation.
Yes, super important.
Become really, really important.
Absolutely.
Yeah, it can really prevent those oh no moments in the software.
For sure.
And speaking of oh no moments.
Oh boy.
That brings us to the big one.
The big kahuna.
Which is failure. And the document describes this as
the ultimate consequence.
The ultimate consequence, yeah, when the software just completely fails to perform its function.
Yep.
The example they give is like a website crashing during peak traffic.
That's a bad one.
Yeah, so a failure is like, it's game over.
It's game over. The software is not working as intended.
It's the most visible problem.
Yeah.
And it really impacts
the user, yeah.
The user, yeah. Like, think about a critical system, I don't know, like air traffic control.
Oh, yeah.
If that fails, that's a completely different
oh my gosh,
level of consequence than like a bug in a Word document or whatever.
Absolutely.
So we've gone from typos in code to, potential system meltdowns.
The whole spectrum.
The whole spectrum, yeah. But the good news is softwaretesting.pdf isn't all doom and gloom, right? It actually offers solutions.
Oh, yeah.
To prevent these problems.
That's the point of it, really,
yeah.
To help us figure out how to prevent all of this from happening in the first place.
Awesome. Well, let's go a quick break. And when we come back, we'll dig into those solutions.
Sounds good. And, since our listener is all about getting things done, let's talk about some of those solutions.
Yeah, let's get practical here.
Okay, so the document mentions a few different strategies.
Mm-hmm.
But one that I think is really interesting is this idea of shift-left testing.
Shift-left testing. I'm not familiar with that.
So imagine, you've got a timeline of your software development process.
Right.
Traditionally, testing happens, way over on
At the end.
At the end, yeah. Almost like an afterthought before you release the software.
Gotcha.
But shift left means you're taking testing.
Okay.
And you're moving it earlier in the cycle, so you're actually integrating it into every single stage.
So instead of waiting for the whole product to be finished.
Exactly.
They're testing along the way.
You're checking for bugs and defects and those faults.
Right.
At every step of the process.
I see. So that's where understanding, the difference between a bug and a fault and all that.
Absolutely.
Really becomes important.
Yeah, because the developers can be thinking about errors even as they're writing the code.
Okay.
The designers are thinking about testability when they're creating their mock-ups.
So it becomes a collaborative thing.
It's a mindset. It's not just a checklist at the end.
Yeah, that makes sense because catching those issues early
for sure.
Has to be more efficient than waiting till the end.
Absolutely. Way more efficient because you're not trying to untangle this huge mess at the very end.
Right. So how does shift-left testing actually work, practically?
Well, there's a few key methods that the document highlights.
Okay.
One is called unit testing.
Unit testing. Okay.
And that focuses on testing individual pieces of code in isolation.
Oh, okay. So kind of breaking it down.
Breaking it down, looking at those little pieces.
So it's like checking each ingredient before you bake that cake.
Exactly. Instead of waiting for the whole thing to collapse in the oven and then trying to figure out what went wrong.
I like that analogy.
Yeah, it's a good one.
Right.
Yeah, so are there other techniques besides unit testing?
Oh, yeah, for sure. So there's another one called integration testing.
Integration testing, okay.
And that looks at how different components of the software interact with each other.
So it's making sure that all the pieces fit together.
Exactly, yeah. So remember that banking app that we were talking about?
Yeah, the one with the time zone issue.
Exactly. So integration testing could have caught that problem before it even went out to the users.
Oh, wow.
Yeah. So it's all about making sure that everything works together seamlessly. Not just that each individual piece is working on its own.
So it's really like, building quality into the software from the ground up.
That's the goal.
Yeah. But the document also says it's not just about, the tools and the techniques, but it's also about the culture. Yeah, it's about creating a culture of quality within the whole development team.
So it's a mindset shift as much as a process shift.
Absolutely. The developers and the testers, they're not separate anymore.
Okay.
They're collaborating.
Working together.
Working together toward that shared goal of making really great software.
That makes a lot of sense. So all this talk about prevention makes me think about what happens when things do go wrong.
Ah, good point.
The document mentions something called root cause analysis.
Oh, yeah. Root cause analysis.
What is that?
It's basically like detective work for software.
Interesting.
So when you find a bug, it's not enough to just, fix it.
Right.
You have to understand why it happened in the first place.
So you're going deeper.
Going deeper, figuring out the source of the problem, not just putting a Band-Aid on it.
So was it like a coding error? Was it a miscommunication? Or was there a bigger problem in the design?
Exactly. And by understanding that root cause,
right,
you can prevent it from happening again in the future.
Oh, that's smart.
It's kind of like if you have a leaky faucet, right?
Okay, yeah.
You could keep mopping up the water, but it makes more sense to fix the leak.
Yeah, find the source.
Exactly. And sometimes that root cause analysis can uncover bigger problems,
Okay.
not just these little isolated mistakes.
So it could be something systemic.
It could be. Yeah, it could show that there's a weakness in the development process, or that the documentation isn't good enough.
Right.
Or maybe even that the team needs more training.
Yeah.
So it's about, turning those problems into learning opportunities.
Absolutely. You're constantly improving.
Now, the document, focuses a lot on testing from the developer's point of view. But what about the user?
Oh, that's a great point. The user is super important, right?
Yeah. Do they have a role to play in all of this?
They absolutely do.
Okay.
In fact, the document specifically talks about something called beta testing.
Beta testing. Okay.
Where you have real users trying out the software before it's actually released. Oh, interesting.
Because sometimes real world usage, throws curveballs that the developers just didn't think of.
Yeah, because we all use software in our own weird ways.
Exactly. And those beta testers can give really valuable feedback.
Right.
They can say, hey, this feature is really confusing, or I found a bug.
Right. And they can find bugs that maybe wouldn't have shown up in the more controlled testing environment.
Exactly. They're like a fresh set of eyes on the software.
Yeah. So I bet that's super valuable for the developers.
It is. It's really important.
So it's all about this feedback loop between the developers and the users.
Absolutely.
It's not just about being technically amazing. It's also about listening to the people who are actually using the software.
Right. It's about creating software that really works for people.
Okay. Well, speaking of listening, what about our listener?
Right. What can they take away from all of this? I think for our listener, what they can take away is that they can be more informed about, the software that they use every day.
Right. So all those terms we talked about.
Yeah. Bug, defect, error, fault, failure.
It's not just jargon, right?
It's not just jargon. It's actually a framework that helps you understand how software is built.
So, the next time our listener has a problem with their computer or phone or whatever, they're not just going to be like, oh, this thing is broken.
Exactly.
They'll actually have a better understanding of what kind of broken it is.
Exactly. And that can actually change how you deal with the problem, right?
Right.
Because if it's a little bug, maybe there's a workaround.
Yeah, you can just ignore it.
Yeah, exactly. Or if it's a more serious problem, like a fault, then you're going to need to contact customer support.
So it's like having a secret decoder ring for the digital world.
I like that, yeah.
But it's not just about being a savvy user, right? It's also about thinking about the software we choose to use in the first place.
Yeah, like if you're always having problems with a certain app or website, that might tell you something about how that company developed software.
Right. Are they even testing this stuff?
Exactly. Yeah. Are they listening to feedback? Are they prioritizing quality?
It's kind of like choosing a car, right?
Yeah.
You want to know if the company has a good reputation, if they make safe cars?
Absolutely. And this deep dive gives you the tools to ask those same questions about software.
Yeah, because we rely on software for everything these days.
Everything. It's in every aspect of our lives.
Okay, so we've gone from those kind of confusing software testing terms to like understanding how they fit into the big picture. The big picture, yeah, of software development and user experience.
And how they affect us as users.
I feel like we've really gone deep on this one.
We have. It's been a great exploration.
So before we wrap up, I want to leave our listener with a thought.
Okay.
We talked a lot about the technical side of things, but really it all boils down to how do we create software that really serves its users?
That's the million-dollar question.
Right. So it has to be, technically sound, but also
user-friendly.
User-friendly, enjoyable to use.
That's the balance, right?
Yeah, it's a tough balance.
It is, but it's a challenge that every software developer faces.
Well, deep divers, that's the end of our journey into the world of software testing.
Sad to see it end.
I know, but hopefully you've come away with, a better understanding of how software is built.
And the important role that testing plays.
And who knows, maybe you'll even be inspired to, get involved in the world of software development yourself.
Yeah, or at least be a more informed user.
Until next time, keep exploring, keep learning.
And keep diving deep.
See ya.